So fair warning, this video might feel like it's out of place. We're still in the circles section, but I'm not going to draw you a single circle in this entire video. We're not even going to make reference to any circles, or use the general form for the equation of a circle that we came up with in the last video. However, by the end of the next video, the connection between this video and what we've already learned about circles will become very obvious. So I guess what I'm saying is maybe just trust me. We're going to take a little algebraic detour, but it's a detour you want to take. And fortunately, it's not that intense. All you really need to know is how to square a binomial. Huh? What? Okay, sorry. If you can expand x plus 3 squared, you have all the prerequisite knowledge you will need for this section. And you're like, I got this. Just distribute the exponent. So it's x squared plus 9. No, it's not. Although for some reason, lots of people seem to think it is. Maybe at some point in your schooling, you learn the acronym FOIL, which tells you that squaring a binomial really results in 4 different products. Oh, yeah, right. It's x squared plus 6x plus 9. I got this. If that's your inner monologue, that's fantastic. To test that fact, let's square a lot more binomials. X plus 1 squared would be x squared plus 2x plus 1. X minus 5 squared would be x squared minus 10x plus 25. And you're like, enough already. I made one little mistake. I got this. It's easy. You don't have to keep giving me examples. Okay, but what if I switch things up a little bit? What if we made it more of a puzzle? What if I asked you to fill in this blank? Could you do it? And you're like, bro, that's called factoring. I've been doing that since high school. Okay, but what if we made the puzzle even harder? What if I asked you to fill in both of these blanks? Because now the problem's getting pretty intense, and this is the one we need to solve. Maybe it would help to go back and look at all the equations above. Note that the linear coefficient, in other words, the number in this column, is always twice the number in this column. Oh yeah, that makes sense. The O and the I in FOIL, informally speaking, will cause that thing to double. Okay, so if this column is always twice this column, then this column is always half this column. So to figure out what goes in the red blank, I just have to cut the 8 in half. It must be a 4. And once I know that there's a 4 in the red blank, it's easy to figure out the yellow blank. The constant term in my binomial expansion, in other words, the number all by itself over to the right, is just the square of whatever's in the red blank. So 4 squared is 16. You get all that? Think you can do it again? Maybe with one last twist? What if I asked you to fill in those same blanks, but I wanted the yellow number first, then the red number? What? Why? Because I'm a mean old math teacher and that's what I do. Or maybe because there's a reason in the next section. Either way, in this example, can you first tell me the yellow number and then the red number? Yeah, I guess. I mean, I'm going to start with the same number, that -6 in purple. And then if I were figuring out the red number, which I'm not, but if I were, I'd cut it in half to get a -3. And I'm going to think about that -3, even though I'm not going to write it down because those were the strange instructions. And I'm going to square that -3 to get a +9. +9 goes in for the yellow number. I haven't written anything in the red blank. Final answer. Pretty good. And now that the yellow blank's done, it's trivial to get the red blank, yeah? Yeah, weren't you listening? I already told you what it was. Just take the purple number and cut it in half, so it's -3. Fantastic. You've aced this section. For our purposes, really the only way it can get any harder is if you run into fractions and stuff. But that really doesn't change anything about the method, as I'll show with the end of video example.